Okay, so welcome back. We'll continue our discussion that we were having on different waste component and how it will actually affect in terms of designing the waste collection system, treatment system, and also final disposal. So we'll continue looking at some of the data from this World Bank report, the picture that you just saw on your screen. So if we go further now, try to look at some of the data. So this global waste composition, if you look at the figure, again, these are all from those World Bank report data. So it's a 44% is our food and green waste. So if you can keep it separate, that can be done composting or anaerobic digestion. We have around 17% is paper and cardboard. 12% is plastic, and this is, as I said earlier, it is a global average figure. And for plastic, I can like for paper in India you will have less paper, which will come out, which as we look at the Indian data. For food waste and greens, we'll see more in India. And if you look at plastic, actually the number was more or less the same. So whatever is the global average, that's the same amount of number. In fact, we found something between 10 to 17% of plastic showing up in the waste stream of some of the cities that we have sampled in India, and we have done sampling at close to 16 to 17 different samples we have done. So, and the numbers comes out to be average around 10 to 17% there as well. So, and there are a lot of other components out there. Each one of them has their potential, but when they get mixed up, it becomes a problem. Now, if you look at in terms of what is happening with that waste, as you can see, open dumping, nearly 1/3 of the waste. Nearly 1/3 of the waste is just open dumped. Open dumping of the waste is creating a lot of environmental issues, and that should be avoided as much as possible. But 33%, almost 1/3 of the waste is just open dumped. Next 25%, it is landfill. We don't know, it's unspecified what kind of landfill, we don't know about that. Sanitary landfill with a gas collection system, only 7.7% is going to sanitary landfill. Nearly 13.5% is recycled. 11% is waste incinerated, like a waste to energy and other incineration methods. 5.5% is composted. So we had, you saw that picture earlier, like 44% is green, but only 5.5% is composted, and we don't have anaerobic digestion listed here. So even if we assume that another 2-3% is anaerobically digested, it is less than 10%. So out of 44% that could have been the organics which is out there, less than 10% is being treated to some form. Rest is just going to the dump sites or landfills, which should not happen. There is a good resource. A resource can be recovered from there. So these are the issues that we have to look at in terms of waste management. We'll look at some more data. If you look at the income and region, like if we are in low middle income, so here nearly 66% is open dump. As you go to the rich countries, you see that open dumping is very less, is less than 2%, and around 2%. Then you have different treatment technologies is being used. You will see some anaerobic digestion, some recycling is more, and then you have like engineered landfill is also showing up, and around 22% is incineration done, like incineration plants, controlled combustion for energy recovery and all that. So as you go towards the poorer country, like if you go to the low income, 93% is just going into open dump. So it requires a lot of work needs to be done in terms of waste management in many countries around the world. So it is a good job market. In fact, if you become an expert in waste management area, that's a good prospect of you have a good career in that, especially in, I'm pretty sure in next 10, 12, 30, 40 years, a lot of demand will be there in that particular area. Same thing if you put it in terms of different regions. North America does more landfilling. If you go to Europe, you will see a good mix of all the different things being done over there in Europe. As you go to South Asia, again, we have around 75% is open dumping, and India being a big part of that. That's not acceptable. Like we have to actually start doing better. So that's what we need to actually focus on in terms of managing our garbage. Same thing by income level. If you put it as you move from high income to low income, you see that the food and green waste percentage increase. For high income, it is 32%. For low income, it is 56%. So here the main problem is, as you go to this low income or low middle income countries, you see that 53, 54, 56% of food and green waste. It is not the food waste coming from our dinner table. It is the food waste which is actually from the farm all the way to the market. A good fraction of that is actually from the farm and all the way to the market. So we need to develop the infrastructure to make sure that we don't waste the food which is produced before it is being even consumed, before it is even being bought by people like you and me. So in the supply chain itself, we are losing a lot of food waste, foods and waste there as well. So that should be fixed. That will actually help the farmers quite a bit as well, and that will help reduce the food waste. If you look at the food waste coming from individual homes, you will find it to be much higher in the developed countries versus in the developing countries and the poorer countries. But since we lose a lot of food waste along the supply chain, that I would say food, not food waste. No, we lose a lot of food along the supply chain. That is a big concern for us. So, and then there are other type of waste out there: paper, cardboard, plastic. If you look at plastic again, you will see more plastic, 13%, and then 11% in upper middle income, and low middle income is also 11%. So in terms of, if you compare food and green versus plastic, from plastic we don't see that much of difference showing up unless you go to very low income countries, which is around 6.4%. But otherwise, all three categories, it's 11 and 13. And again, India, we based on our data also, we found somewhere between 10 to 13, 14%. So it kind of matches very well with that too. So plastic again is getting a big problem. If we get a chance, we'll talk about some plastic waste issues as well. This graph, you will see it at many times at different locations, different discussions, whenever you will talk about waste management. So as the GDP of the country goes up, waste production goes up. We become more wasteful society. So this data, what you're looking at, all those data points here, your y-axis here is the waste per capita. So here it's a waste per person per year. So this much, sorry, we have to get those off. So this is your waste per person per year. So that's what the data you are looking at. Those this is and in the x-axis it's a GDP per capita, which is actual value is right here, and the predicted is the best fit line that you see over here for like looking at the correlation. So as the GDP per capita is going up, you can see more and more waste is being produced. And that's what we have seen that pretty much everywhere in the world. There will be only few countries where you will see that this is one outlier right there. That's, I think, Luxembourg, which has a very high GDP per capita, but the waste production is less because they have those kind of systems in place. But in general, you see a little bit of trend here where you try to kind of goes down. But initially, you see that there is, as the GDP goes up, you see an increase in waste production. So that is happening in pretty much everywhere in the world. Now, waste segregation, these are the different types. You can have organics, you can plastic, electronics, you have non-recyclable, mixed in paper, glass, metals. Going by doing each and every waste recycle, like try to recycle each one of them separate, that will require lots of effort and a lot of money and all that. So that's why the focus more is on, why don't we just do wet and dry, as the government is suggesting right now. If we do the wet and dry, so we'll have plastic, electronics, paper, glass, metals, and all those in one bin, and then organics in the other bin, and then we can separate these out in the material recycling facility. So what can we do with the waste? For the organic waste, we can make compost. We can do biogas. We can produce biogas, anaerobic digestion produces biogas for electricity. You can the residue coming from here can be composted further and make fertilizers. Compost can produce fertilizers. You can make biochar as well. Biochar, hydrochar. In fact, we have done some work in our lab where we have with the food waste and the yard waste, the green waste. We have produced hydrochar using the hydrothermal carbonization in our lab, which and we have do the pelletization of that as well. And those pellets have similar calorific value as for lignite coal. So it can partially substitute coal also in thermal power plant. It can be used as an adsorbent material. We have our research is also suggesting that it can potentially be used as an energy storage material too. So we have done some cyclic voltammetry test on that to find out whether it can be used as an energy material. So think about, say you have your food waste, which first of all you should not create food waste, but just in case if there is a food waste from your house, went to this hydrothermal carbonization, we made that carbon material. 1 year, 1.5 years down the line, you bought a cell phone. The same carbon material is in the battery of your cell phone. Would it be cool, isn't it? So you can make resource recovery from that. And if we can do those in the lab scale, we find a lot of potential. We have to, of course, do some pilot test. I'm looking for some industry partner who can partner with us. We can do a big pilot, and if we can demonstrate that kind of stuff, that will really help solve some of the issues of agricultural residue burning. You see that every year during the winter months, we see all these issues of pyrali burning and all that. So we have to make it economically profitable for the farmers, for somebody to get those agricultural residue and do some value-added product like this. So that research is all out there on the internet, on several newspapers. It was covered, so you can have a look at that as well if you're interested. Plastic, we can do mechanical recycling, we can do feedstock recycling, we can do energy recovery, and the landfill. So those are landfill is the final option. Mechanical recycling, we'll talk about that in slightly more detail. You can do pelletization, extrusion, injection. Basically, you take the plastic and try to make new plastic out of that, new plastic material. Feedstock, you take the plastic and try to do some basic material, like you do the pyrolysis to gasification, do the waste to oil. So you make different products. You're not making plastic, you're doing different product using the same crude material. Incineration, you burn it to get energy. Plastic is essentially coming from crude, so it has a good calorific value, so you incinerate and get that energy out of that. So, and then you have e-waste. For e-waste, you can go for e-waste recycling. You may have heard about that in Japan. Unfortunately, last year we could not have the Olympic due to COVID. Now this year we were looking forward to Olympics during the summer. So all the medals that will be given to athletes or whoever will win the different events there, they are all metals, the gold, silver, and others has been recovered from recycled from the waste, from the metal waste, as most of it coming from electronic waste. So from e-waste, the precious metal recovery can be done, and that is being used. So here you have you take your this is a kind of how it is done. This is one example from one of the service provider where they take the waste. You have the electronic items are used up. You take that, then you. So you look at the working electronics. If it's a working condition, you try to use it for. Oops, sorry, just go back up. Sorry for that. So you try to look at the material. If it's a working electronics, try to reuse that. Then you take the device detail. Now, if whatever is the old data, you have to destroy it permanently. That the privacy issues. Then you can resold through remarking channel. So if it's a working, just get rid of old data, and then you can format and all that and use it. If it's not working, then it enter the recycling process, dismantle and shred to optimal size, separate parts are sorted. Plastic, paper, plastic, glass, metals, and others can be recycled for most part. The precious metal, the printed wire board and others, that needs to do. We have to create a new, we have to do the precious metal recovery. So that's where all those pyrometallurgical and hydrometallurgical processes comes in picture, and we need to produce. That's what has been done in China to get those material. Paper, you can collect the paper, shred it, do the pulping, de-inking, drying, rolling, new paper. If you get a chance, there are paper mills many places in India. If you get a chance, visit a paper mill. It's a very nice place, a very interesting place to go and see where all these paper. We all of us use a lot of paper on a daily basis. So you can go and see how it is really made, or you can find it on YouTube as well. And I firsthand, like may have visited 5-6 paper mill just in last 2-3 years, and we have seen how this recycled paper is being used. Many times actually they're getting recycled paper from overseas because that quality is better. Source segregation was done better over there. So they get those recycled paper actually coming from overseas rather than being able to use Indian paper, because the Indian paper gets so dirty. We are not doing source segregation properly. So, but you may have seen your classmate and all those different notebooks where it says 20% recycled content, 15% recycled content. So this is actually what it is coming from it. So your recycled paper coming out from there. Glass, you can sort by color, remove cap, crush it, and then you melt it greater than 1500 degrees centigrade and make new glass. You get a glass blower section and new glass is made from there. Metal waste management, you can do sorting of here we use a lot of automation system in terms of ferrous. For the ferrous metal, we will use manganate, which is quite obvious. We'll use the manganate. So there are, in order to recycle different types of scrap metals, we need to separate from each other. And also we need to separate from paper and plastic. So in terms of separation of the scrap metal, we look at it's passed through a radiation detector. So any radiation scrap is taken out first. So you have a radiation detector. So any stuff which is to separate radioactive scrap from the rest of the scrap metal. So paper, plastic, glass, here they are trying to take it out, so that's taken off. Then you are doing shearing, hydraulic machinery capable of, they can cut metals into manageable size. Then it goes to shredding. So here shredding is done for that metal. Then after shredding, it will get ferrous removal, metal separation. So you use a manganate and do the ferrous removal. Then you can do is using eddy currents and high pressure air flows and liquid floating system. You can do like aluminum cans and others. So you get from here you separated ferrous using manganate, so it is coming down here, and then your aluminum and other stuff which is coming down finally here. So that's your non-ferrous scrap. Then you can do the baling of it, ferrous, and you bale it and make it in a compact cubes, which is taken for transportation. Then it's transported to steel mills and other places. Then recovered materials are melted down in a furnace along with you get the high quality raw material. It is poured into casters and shaped into ingots, and you make different new products out of that from any metal recycling. Metal recycling has been happening in the country for quite some time. Again, it does not get metal does not get dirty very easily as well, so it's easy to recycle those material. Inert waste is generally sent to a landfill. It can be used in construction also as a substituent material, as a material, as a secondary material. Only non-hazardous waste can be used in construction. We have to be very careful in terms of when you are using any waste material in terms of construction. Even when we see these days we are doing a lot of biomining and mining of the old dump sites. Legacy, we call it a legacy dump sites. It's good to do that. But again, we should do the due diligence of all the different materials we are recovering from these landfills, from the old legacy waste site, to make sure there is no contaminant. It should not happen that we have taken the point source and now we are making a non-point source. We are spreading around pollution all the different places. Whatever is coming out of these legacy dump sites, they have to be looked at very carefully in terms of making sure there is no heavy metals, and if the heavy metals is there, it should be in a non-leachable form. So what is needed is a beneficial reuse risk assessment protocol. That's very, very important. We need to have a beneficial reuse risk assessment protocol that needs to be followed whenever we are trying to use waste in construction or any application in where it will come in contact with human contact or rainfall contact. Otherwise, we may solve one problem but create several other problems. So we need to be careful about that. So in terms of waste management, if you look at, there are 6 major types like components. So we have, of course, waste generation, handling, separation, storage, collection, Then you have separation, processing, transfer, transport, and finally disposal. So in terms of, again, the same thing has been written in terms of functional elements. So we already talked about some of these stuff so far. So waste is handled, it is separated, it's collected. Collection is one of the costliest portion of waste management. Try to try to do the resource recovery as much as possible, and then like finally, if it cannot be done, it is send it to the landfill. So in terms of waste generation, what is waste? It has no further value to its owner. Like there is a quote that waste is a misplaced resource. It is actually a misplaced resource. It's not waste, it is a misplaced resource. So some has further values to others. So chemical ingredient could be there, electronic part, compost for your garden. Some are just waste, like food packing, product containers, household hazardous waste. They need to be managed as a waste. But as a technology develops, some waste which was previously considered as waste may have renewed value, like food to methane production. 20 years ago, 25 years ago, if you tell somebody that I'll take food and make methane and make electricity, and that with that electricity, even a BMW will plant may run, part of the energy will come from there. It wasn't, people may say that what you're talking about, but today it's realistic. It is happening. It is happening where people are using these as a resource. So best place to do the source segregation is at source. You put it in several containers where you have blue bin, yellow, different types of bins. Separate the valuable from the waste, like paper, metals, plastic. Avoid contamination. Proper on-site, I think we talked about that already. Need the cooperation of citizen from separation of work, like at home, at work, houses, versus like an individual house versus a small apartment complex versus big apartment complexes. Small apartments are called condos, or the big apartment complexes. If you mix it all together, it gets contaminated. So if you can keep it separate as much as possible, and then you can process it into composting and all those different kind of stuff. Collection is gathering the waste and recyclable. Transport to recycle or transfer station or disposal facility. Many places transfer station is used where there's a smaller truck brings the waste to the transfer station, and then it gets transported in a bigger truck, and then it is taken from there to the landfill or final disposal point. So whether we need a transfer station or not, that is a function of the distance to the disposal site. So if the distance is too far, we try to go for a transfer station. Collection is most expensive component of solid waste handling. So if you can come up with some good route optimization, that always saves money. Industrial waste are held separately than municipal waste. We don't mix them together. We work, industry waste is handled separately. So in terms of processing and transformation, it could be simple as opening a bag and then just looking at the waste. You can do some shredding. You saw those pictures just now. You can do some shredding. You can do compacting to reduce shipping cost. You can do some screens and mechanical separators. Different types of screens are used. Then you can, when the waste is, you can do some incineration, and composting is also kind of considered as transformation of waste to do some resource recovery from there. Transfer and transport. This is a transfer station, a smaller collector vehicle, as I said, bring the waste to the final destination, which is a landfill or incinerator, or to a transfer station where it is further compacted to truck, rail, or barge. Some places they use rail. In New York City, they use rail, and even in like many places, like we saw that in Chile, or if you look at in Singapore, they use barge. Truck is the most common one. Then finally, your disposal, which is the landfill of nothing can be done with the waste. If you cannot do anything with the waste, it ends up in the landfill. So landfill should also be engineered structure. A modern landfill is an engineered facility. It provides try to maximize the methane production. So you can do like a bioreactor landfill. You make sure that leachate does not escape. Quicker the methane is produced, the faster the landfill is stabilized. So that if it's faster still, then we can reuse that. So if you can just have the regular dry tomb, then it's not possible. You have to use it as a treatment system, and that is called actually making the landfill as a bioreactor landfill. If you have a waste to energy ash, that could be used for construction, you can do it for as a construction material and all that. So it is it is being used for different application as well. So let's stop here for this particular video. Then we'll get into the next video and explain some more aspect of waste management in detail. So thank you. Again, these videos are a supplement to your regular classroom class. Do try to watch it before the class, before we cover this topic in the class. So thank you and see you again.